Hello everyone. Welcome to IS 300. Today we're going to talk about cloud solutions for the Internet of Things. Our key words for this week are cloud computing, the Internet of Things cloud, virtualization in IoT cloud, vertical supply chains, and federation. It is a natural integration of cloud and IoT. The evolution of those two technologies is the wave of the future. And so in this chapter, we talk about the need to integrate the Internet of Things and the cloud, the benefits and the challenges, of course, the role of the evolution of cloud-based IoT systems towards federated ecosystems. We'll talk about the architectures, requirements, and some of the challenges. Cloud computing is basically famous for large storage capacity, processing, and security features. Unlimited, actually, if you think about it, because you have all kinds of resources available that can be merged and migrated through the cloud. The Internet of Things, then, is known for addressing the challenges of real-world distributed devices, some of them with limited processing power and storage, Bluetooth devices, and some of the other devices that we talked about last week, smartphones and voice over IP technologies and things of that nature are making the IoT a very popular technology, but it also creates some challenges. Most of today's social problems can be addressed, at least many of them can, because of the convergence of the cloud and the Internet of Things. If you think about it, it is, again, a natural integration for those two technologies to integrate, but along with the integration and the flexibility also comes some challenges. As a review, we talked in week 1 about the National Institute of Standards and Technologies, their definition of cloud computing, and I'll repeat it here. Ubiquitous, which means 24/7, 365, any place, anytime, on-demand network access to a shared pool of configurable computing resources, rapid provisioning, minimal management effort, and limited interaction with service providers. That is, in a nutshell, cloud computing. Of course, the cloud is a layered architecture, and it's got service-driven models. The cloud architecture, has 3 service models, and this is a review from week 1. Software as a service, platform as a service, and infrastructure as a service. The cloud architecture also has 4 layers: the application layer, the platform layer, the infrastructure layer, and the hardware and/or data center layer. Basically, there is an interaction between the application and the platform. There is an interaction between the platform and the infrastructure, and then there certainly is an interaction between the infrastructure and the underlying physical hardware. The hardware layer, routers, switches, cooling systems, electrical grids, things like that can be managed and controlled. The data center itself. I worked in a data center for many years, big, large mainframes back in the day in data centers that contained nothing but hardware, cables, wires, switches, routers, hubs, things of that nature that had to be managed and had to be contained. Usually it had to be up and running 24/7, 365. The infrastructure layer, physical resources that can be then partitioned to create virtual machines such as Amazon's EC2. The platform layer, a combination of applications and operating systems and the tools or the hardware that runs that platform. Microsoft's Azure is an example of a platform layer Architecture, the application itself. Google apps, Facebook, which we all use, social media apps, most of the social media apps, in fact, not just Google, but most of them are a cloud-based software as a service architecture. Then you have four types of clouds: public, private, community, and hybrid. The integration of the Internet of Things and the cloud then has introduced new service models: sensing as a service, not to be confused with software as a service, which will analyze and process environmental data on demand. Sensor as a service is live environmental sensor data from existing infrastructure. Sensing and actuation as a service takes devices that sense motion, actuators that actually generate motion, and assemble those and assembles and processes those environmental data and makes it available to consumers. Data as a service, business critical data from the cloud to customers. If you think about marketing data that can be sold, you might see some of those messages that says your data will not be sold, but data as a service is simply the selling of data as a commodity that can be sold. Database as a service is basically the ability to lease or rent as a utility a database itself, not the data, but the database itself. And then there's Ethernet as a service, broadband channels that can be made available to users that require high bandwidth, fiber optics most of the time. Wi-Fi can be derived from Ethernet as a service. So you bring Ethernet to a facility, and then you can use a Wi-Fi router connected to the Ethernet to provide broadband capability to users in a specific facility. That can be then sold as a service. All of these new service models are a result of the merger of IoT and cloud computing. The contribution of cloud computing to the Internet of Things: Dropbox, which I use regularly, and a Google Drive. You probably use that as well. Salesforce for an example of software that must be encrypted and authenticated, because usually that is a customer relationship management software with customer information. Salesforce, very popular customer relationship management system that I also use on a regular basis. And then Google Cloud. If you have a Gmail account, you are probably using you are using Google Cloud. Those are all very popular and very common implementations of the integration of cloud computing and the Internet of Things. The drivers for integration of cloud and IoT: communication, the ability to automate, to share applications, and to share data from those that's generated from those applications. The storage capabilities in terms of big data. You've heard the term big data, very large amounts of unstructured or semi-structured data from a variety of databases and data sources. And then the cloud itself, which provides computational facilities that helps manage the data processing and aggregation or combining of data. Supports also scalability. As a result of the migration of IoT and cloud platforms, there are some issues that have been created as a result of that. Context awareness. Because you have data from a variety of sources, there needs to be a clear context for each one of those sources of data so that it makes it a clear picture of what data is being processed and what needs to be processed. Heterogeneity, basically, because of the complexity of combining a variety of IoT devices, the heterogeneity simply makes that problem even worse because of the complexity. Standardization, also a problem because you have a variety of data from a variety of sources with a little or no formatting or no standardization, certainly, in the formatting of that data. So you get a variety of data from a variety of sources. It's going to be a hodgepodge of formats. Node identity or middleware, the need for each of the layers to talk to each other, APIs, middleware, all one and the same. And so the availability of middleware or the development of middleware, also a challenge when you're migrating IoT and cloud platforms together. The identity of nodes in an IoT environment, because you have such a huge number of nodes, basically endpoints, that are connected to each other. There needs to be some way to identify those devices and the data that's been retrieved from those devices, so that creates a problem. Energy management is a new problem because now you have a variety of devices, small devices, usually independent with their own power sources, and those power sources are usually battery operated. When the batteries are depleted, then the device is no longer functional, and so managing energy becomes an issue. Fault tolerance, of course, is always keeping those systems up and running. Depleting batteries is going to reduce the fault tolerance. Erroneous values sent by sensors is also a problem. Calibration or over time, calibration becomes more inaccurate. That's also a problem. Communication failures can also be a problem. So the recommendation in this week's reading is that we migrate to solar power as an alternative to battery-operated components. It's environmentally friendly and certainly more reliable and not prone to failures because of the loss of battery power. And then also communication protocols such as TCP/IP to make sure that those devices can communicate with each other. All of those things are not necessarily going to be deal breakers, but combining all of these things makes for a challenge in migrating IoT and cloud and merging those technologies together. Cloud federation. Federation simply is the combining of multiple devices and multiple environments from two or more cloud service providers for the purposes of load balancing, traffic management, and accommodating spikes in demand. Cloud federation requires one provider to rent computing resources to another provider. Then cloud federation allows for the merging of software, infrastructure, and platforms that can be accessed by clients across the internet. That's basically, if you're talking infrastructure as a service, platform as a service, software as a service, those models or the merger of those models becomes IoT as a service, the Internet of Things as a service. So the three service models then can be combined into yet another service model called IoT as a service. Federated cloud computing simply takes multiple components from multiple providers and makes it into a simple, or not a simple, but a single system that is then used for purposes of providing unlimited, if you think about it, unlimited capacity and unlimited resources. Virtualization. One of the benefits of cloud computing is virtualization. So if you take that virtualization, which is simply taking multiple virtual machines or creating virtual machines, multiple virtual machines on a single physical device, physical operating system. So you have one physical machine that is the host, and you can create multiple operating systems that run in that host, and it appears as though each one of those virtual machines is a single entity unto itself. You use a hypervisor to manage the virtual machines, also called a virtual machine monitor. It builds services that hide the complexity of the underlying hardware and software. In fact, the underlying hardware and software is not necessarily known to the user who's running the virtual machine. To the user of the virtual machine, it looks as if the virtual machine is a single entity, not necessarily running on a physical platform underneath. Monolithic IoT, which is what we're talking about, is the gathering of all of these different IoT systems, IoT as a service, and running these capabilities in a cloud environment, which gives you multiple instances or instantiation, optimization, the management of the IoT as a service, reliability, scalability, quality of service, security. All of those things that are provided in the cloud are also provided in IoT clouds. Vertical supply chains, then, when you're talking about multiple cloud providers and multiple IoT services, that becomes a vertical supply chain. Therefore, it requires the metering of information in order for purposes of billing, accounting, and service placement and decisions along those lines. Service level agreements should be in place, and we'll talk about that in later chapters. But a vertical supply chain in the cloud context simply means you have multiple cloud users, multiple providers, and multiple services that are being operated as a single entity. It requires coordination and cooperation of various IoT cloud providers. So the bottom line is an IoT cloud federation is a group of interconnected IoT cloud providers. It is decentralized and it provides sensing and actuating for devices that are IoT devices primarily. There must be a service level agreement in place. There are always going to be some constraints because you're talking about multiple vendors and multiple providers. And then there's a term called cross-cloud federation, which permits every IoT cloud operator to extend its virtual resources, thereby increasing the number of virtual machines and containers that can be made available to other IoT clouds. So if you think about the internet as the network of networks, you can think about IoT cloud as a network of IoT and cloud providers that are made available over the internet. Cloud Federation, what they call automatism or automation, keep it simple, automation, scalability, so you have the ability for home IoT and foreign IoT, both that can satisfy the needs depending upon the nature of the requirements, interoperable resources, and virtualized IoT resources that allows, through federation, for the joining of multiple cloud providers without changing the security policies. Of course, that implies a certain amount of risk as well, because the security will only be as good as the policies that are implemented. And when you're talking multiple vendors, then there can be some additional security issues that have to be considered. In conclusion, there is a tremendous amount of resources that are made available as a result of the migration and integration of IoT and cloud. Those tremendous benefits are not without risk. It represents a giant step forward, in a leap into the future, as it says here. New applications that are being introduced for purposes of business and research. The IoT cloud has evolved into federated systems, a combination of systems, if you will, which are derived from the integration of multiple Internet of Things cloud providers. It provides unlimited capabilities, but it also includes unlimited challenges and risks. This has been the discussion of Chapter 2 in cloud computing and the Internet of Things.